Hey everyone. So this is a video that is going through practicing determining the name or the formula for ionic or covalent compounds. And so we're going to be looking at these 8 specific compounds. And you can see in this table either the name or the formula is missing. So we're going to need to go back and forth between the name and the formula. Another thing we're going to add to this table is whether the compound is ionic or covalent, because that's really a key distinction when you're naming things. So this video is going to be looking at these 8 specific examples and giving you a chance to practice. But if you are interested in a more general overview, breaking down all the steps of naming binary, ionic, or covalent compounds, check out the other videos on naming, which are on this channel. So let's take a look at the first compound in the table. So for this compound, we are given the formula, but not the name. And so we're going to need to name this compound. And so if I look at my flowchart for naming, and again, if you want an explanation of this, check out the other naming videos on the channel. But the first thing that I need to determine to name something is whether it is ionic or covalent. And so for this compound, how am I going to determine that? Well, that's where the periodic table is going to come in. And so we need to locate silicon and bromine on the periodic table. So there's silicon. There's bromine. So these are both on the right side of the table. Bromine is a nonmetal. Silicon is a semimetal or a metalloid, but that when combined with a nonmetal is going to give us a covalent compound. So we know that we're going to need to use our covalent naming structure. And I'm also here going to fill this out that we have a covalent compound. Okay, now we need to determine the name of this compound. So I'm going to use my covalent naming scheme, which is this half of the table. So to name this, we just need to name the first element and then name the second element. And those names are going to consist of a prefix, which indicates the number of atoms of that element and the element name. And then for the second element, that ending is going to get changed to IDE. So if we apply that here, our first element is silicon, and there's 1 silicon. So the prefix for 1 is mono, but because this is the first element in the compound, if there's only 1, this gets omitted. So I don't need to write mono, I'm just going to write silicon, and that's the name of the first element. And then for my second element, I have 4 bromine. The prefix for 4 is tetra. So I am going to write tetra. And then my element, but I am going to change the ending of the element to IDE. So I have a prefix indicating that there's 4 bromine, and then because this is the second element and the end of the compound name, it's going to end in IDE. So the first element is named silicon tetrabromide. Okay, so let's move on to our second compound in the table. And again, we need to provide the name, but we're given the formula. So here we have a compound made up of 2 rubidium and 1 sulfur, and we need to determine if this is ionic or covalent. So if I go back to my periodic table, here's rubidium over here on the very left, group 1A, so that's going to be a metal. And then sulfur over here on the right-hand side is a nonmetal. So we have a metal and a nonmetal, and that means that we have an ionic compound. So if I go back to my flowchart, I'm going to want to use my ionic naming rules. And so I'm going to name the cation, or the positively charged ion, and I'm going to name the anion. So let's start by naming the cation. So I need to determine if my ion consists of a single element or if it's a polyatomic ion. So if we look at this, this is a 2-element compound. So we know we're looking at a single element cation, which is the metal, and then a single element anion, which is going to be the nonmetal or the sulfur. So we're going to use the rules for naming a single element cation, but we do need to check whether or not we need to include the charge with the name. So we need to include the charge if it's an element that can form ions with more than one charge. And so this kind of table is very handy for this. So you can see there's some elements like iron where it can form both a 2+ and a 3+ charge, which means I would have to indicate the charge in Roman numerals like it's shown here when I'm naming this compound. But rubidium is a main group metal. It only forms an ion with a +1 charge. And because of that, and the fact that we can determine the charge from the periodic table, because it's in group 1A and it forms a +1 charge, we don't include the charge in the name, because that's just redundant information. So all we need to do to name the cation is write the name of the element. So we've got rubidium. All right, now we need to name the anion. If I go back to my flowchart. So as with cations, we can have either an anion made up of a single element, or we might have a polyatomic ion. But we just have sulfur here, so we're going to look at a single element ion. And to name that, all we need to do is write the element name and change the ending or change the suffix to IDE. So sulfur is my element, but I'm going to change that ending to IDE so I get sulfide. And so that's the name there. And one thing I want to point out is with ionic naming, you do not use prefixes to indicate the number of atoms. And this is a common mistake to kind of confuse that with covalent naming. So even though in this formula there's 2 rubidium, I don't put di on the front to show that. I don't need to because I can figure out the charges of these 2 ions and I can figure out that they go together in a 2-to-1 ratio just based on the charges. And we'll see how that works when we go the other direction. But that's just a note on this, and don't ever use prefixes when you're naming ionic compounds. Okay, so let's look at the third compound on the list. So now we're given the name, but not the formula. So we're going to need to work in the other direction. And so again, we're going to figure out whether this is an ionic or a covalent compound. And there's a couple good ways here. So one is if I go to the periodic table and I find copper, it's a transition metal, which makes it a metal. But I also could tell this is an ionic compound because the charge is included in the name. So it's copper 1. So we have a copper +1 ion. And then sulfate. Now, here's a clue here. This T here means that I'm probably looking for a polyatomic ion, because if it was a single element ion, it would end in ID as in dog, IDE. And so if we look at a table of polyatomic ions, we can just locate sulfate on that table, and it has the formula SO4 2 negative. So I'm going to put this on here. So my ionic compound, in here, is made up of a copper +1 ion and a sulfate ion, which is SO4 2 negative. So I can now make the formula. All I need to do is combine these 2 ions into a compound which has a net charge of 0. So I need the plus charges on the copper or the positive charges to cancel out all of the negative charges on sulfate. But because sulfate has a 2 negative charge, I am going to need 2 copper ions, which each have a +1 charge, to cancel out that 2 negative charge. And so my formula, I'm going to have 2 copper, so I indicate that by using the subscript 2, and then 1 sulfate. Since I only have one of my polyatomic ion, I don't need to put parentheses about this. It's just SO4. So moving on to the next compound, we've got aluminum oxide. And again, we are given the name, but not the formula. But first, we still want to determine if we have an ionic or a covalent compound. So back to the periodic table. Here's aluminum. It's to the left of the semimetals. So it's a metal. Okay, so I got a metal. And then oxide, it's oxygen. So that's a nonmetal. So metal plus nonmetal, I'm dealing with an ionic compound. But now I need to determine what ions I have so that I can write the formula. So if I go back to my periodic table and I look at aluminum, aluminum is in group 3A. It forms a 3 plus charge. And you can check if you have this table of common ions that aluminum only forms a 3 plus charge. So I know I've got aluminum 3 plus in this compound. And then I have a single element anion, and I can tell this isn't a polyatomic ion because it ends in IDE. So if I look at where oxygen is on the periodic table, it's in group 6A. That means it would have to gain 2 electrons to get to a full octet or a noble gas configuration. And so it's going to have a -2 charge. So those are the 2 ions I have. However, I need to combine these in a ratio where the net charge is 0. So right now I have a 3 plus charge and a 2 negative charge. And 2 doesn't go into 3 very well, but we can find some things, basically the least common multiple of these. So if you mess around a little bit, you can see if I were to have 2 aluminum, which would give me a total of 6 positive charges, I can then balance that out with 3 oxygen. So that would give me a -6 charge. So +6, -6, my net charge is 0. And that means my formula is going to be 2 aluminum and 3 oxygen. So there we go. Okay, our next compound is P2F4. So here we need to figure out the name from the formula. Again, let's start by determining if this is ionic or covalent. So I'm going back to my periodic table. I've got phosphorus and I have fluorine. These are both to the right of the semimetals. So they are nonmetals. So I have a nonmetal plus a nonmetal. And so I have a covalent compound. So that means I need to use my covalent naming system. So if I go back to our flow chart, we got covalent. We're going to use covalent naming. And that means we're going to use prefixes to indicate the number of atoms. So here we have 2 phosphorus. So we'll just use the prefix di. And then it's the first element, so I just put the element name, so phosphorus. So there's my prefix there. And then for the second element, I'm going to use the prefix tetra to indicate that there's 4 fluorine. And I need to change the ending to IDE. So I have tetrafluoride. And that's it. Okay, now to name this compound. So I've got a formula here, FeCl2. Fe is iron, Cl2 is chlorine. Iron is a metal, it's a transition metal located here. And we can see from this table of common ions that it can form either a 2 plus or a 3 plus charge. So that means we are going to need to include the Roman numerals with the charge in the name. And also we're going to have to figure out whether this ion is in the 2 plus form or the 3 plus form. So the way to do that is to first figure out what the negative charge is on the anion. And so my anion is of chlorine. Chlorine is located in group 7A of the periodic table. So it has a -1 charge, which would give it a full octet with 8 electrons if you add 1 electron. So I know I have 2 chloride ions with a -1 charge. By the way, I'm dealing with a metal and a nonmetal and ions. I kind of skipped over this part, but we do have an ionic compound. I'll fill that out. So I've got two negative charge, and I know that this compound has a net charge of 0. So I need to figure out what the charge is on this single iron ion to give this a net charge of 0. That means I have to have the Fe2 plus form for my iron ion. And so to name the first ion, I'm just going to write the name followed by the charge in Roman numerals. So I have a 2 for the 2 plus charge. And then I do not need prefixes to indicate that there's 2 chloride ions because I don't use prefixes when I'm naming ionic compounds. I don't need to because I can just use the charges to work out those numbers. So it's just going to be chloride. And again, the second element, the name, the ending gets changed to IDE. So here we have this compound. We're given the name, we need to determine the formula. So this compound is dinitrogen pentoxide. We want to know if this is covalent or ionic. Another clue, in addition to just determining whether you have metals or nonmetals, is the fact that this name does have prefixes. So that's a dead giveaway that it's a covalent compound because we don't use prefixes in ionic naming, but it is good to verify. We've got a compound made up of nitrogen and oxygen. These are both nonmetals, so it is a covalent compound. And with covalent names, they basically spell it out for you. So I know I'm going to have 2 nitrogen and pent, which is penta, the prefix penta, which stands for 5. So I'm going to have 5 oxygen. And there we go. That is the formula. Okay, last compound, calcium nitrite. So let's figure out what type of compound we're dealing with. So I have calcium, which is on the left side of the periodic table. It's a metal. And I have nitrite. And again, this T here, instead of a D, is a good clue that I need to look at my polyatomic ion table and see if nitrite is on it. Here we go. Here's nitrite. Careful not to confuse it with nitrate, which has an extra oxygen. Nitrite has the formula NO2 with a -1 charge. So there is my formula for nitrite. I do need to figure out what my calcium ion looks like and what charge it has. So because calcium is in group 2A of the periodic table, it forms a 2 plus charge. So my calcium ion is going to be Ca2 plus. Now I just need to combine these ions into a compound that has a net charge of 0 to get my formula. So I have 2 positive charges from the calcium ion, but only a -1 charge on the nitrite. So I am going to need 2 of those to balance out the positive charges. So I'll have 1 calcium and 2 nitrite. Now, since I have a polyatomic ion and I need 2 of them, I'm going to put the nitrite inside parentheses. And then I'm going to add a subscript indicating how many of those nitrite I have. So I have 2. And so I get the formula calcium with 2 nitrite. Okay, so that takes us to the end of the table. We have gone through all your compounds, but I'm going to show the whole table here with the answers, just in case you missed any of those. So feel free to pause the video and check your answers against this table. And I really do encourage you to do this type of practicing where you've got a mixture of ionic and covalent compounds, and you're making sure that you can go from the name to the formula or from the formula to the name. So I hope that this video was helpful. If you want more explanation of naming, check out the other videos on this topic and enjoy naming ionic and covalent binary compounds.